So this is a video review of the homework, so let's get started. We are going to do number 2 here, the second 2 on this page, and we are given what? We're given 280 milliliters of oxygen. So there's my oxygen, and I have 280 milliliters of it. That's something I have. I'm going to write that down. I always start with the number given to me. So 280 milliliters of oxygen. Always make a good habit of writing down the unit and what you have, because in stoichiometry we're going from information of one chemical to another. In this case we're going to go to propane, and they want something about propane. They want well, they should say milliliters, okay? So sorry about that, milliliters, typo. Any case, I need a balanced chemical equation in order to do stoichiometry, so let's do that, because stoichiometry is nothing more than an application of conservation of mass. Any case, 3 carbons. I only have 1 carbon on this side, so I'm going to throw a 3 here, coefficient in front. I have 8 hydrogens, so to get 8 hydrogens I'll need a 4 here. And now to balance my oxygen, now I have 6, right? 3 times 2. So 6 oxygens plus 4 in front, plus 4, I have 10 oxygens. And on this side, the only place with oxygens is the O2, so I need a 5 in front. So it's a 1 to 5 ratio. So I'm starting with 280 milliliters of oxygen. A volume to volume question is going to be one step, because a volume is proportionate to how many? Okay, twice the volume, twice the number of molecules. We know that 1 mole of any molecule of a gas at STP is 22.4 liters as long as we're at STP. So if I have twice that amount, I have twice the volume. So volume and how many, as I keep saying, which is mole, is directly proportionate. So I don't need to convert to anything to do this. I can use this ratios in front, which are how many ratios. So let's get rid of O2. O2 goes on the bottom. I want propane, C3H8, and I know that there's 1 of these per 5 of these. Okay, so now listen. O2 cancels, and I'm left with C3H8, and I started with milliliters. I didn't cancel milliliters. And of course, let's find that number. So I put that in my calculator, and magically I have 56. Okay, and of course it's 56, and I should write this better, 56 milliliters of my propane. A 1-to-1 problem, or it's a one-step stoich problem. All right, what makes it stoichiometry, as I keep saying, is that I have this step where I'm converting from one chemical to the other. Okay, so let's go on to the next problem. Number 6 is the next problem, so let's get started. What are they giving me? They're giving me 100 grams of magnesium chloride, MgCl2. And what do they want? They want the exact number of molecules. They want the molecules of hydrogen gas. That's exact number. Okay. Well, it's starting with 100 grams of magnesium, so my starting point is right here. And I want to get to, what? Hydrogen gas here. So I want to take some information about magnesium, in this case grams, and convert it to the actual number of molecules that I produce. So the first step is I write the number given to me, which is 100 grams. And I get rid of 100 grams by putting in grams here, and I want a mole. And 1 mole is equal to how many grams? Well, first of all, we have this formula, so we need a formula mass. So in 1 mole of magnesium chloride, I have 1 magnesium, 1 times 24. Now I'm getting this 24 from the periodic table. It's the atomic mass. A mole of magnesium is equal to its atomic mass because we made it that way. Another lecture for another day. And of course we have, in 1 mole of magnesium chloride, we have 2 moles of chlorine atoms. 2 times 35, we'll just say. Round that off, it's okay. And we get 70. Add these together, I get 94 grams for every mole. So 1 mole is equal to 94 grams. Now, I'm getting rid of my grams to get into moles. And the reason that I'm doing that is so that I can get rid of my magnesium chloride to get into the chemical I want. In order to get rid of the chemical given to me, which was in this case magnesium chloride, looks like I thought I was magnesium, bad Grodsky. So they gave me information about magnesium chloride. So this is what they started with me. And I get from 100 grams of magnesium chloride, I can't times that by the ratios here because it's not a how many number. So I convert to moles first, then I get rid of it. So I know that there's 1 magnesium chloride for every 1 hydrogen. So magnesium chloride is canceled. I'm using my units. All right, now, next step. What do they want? They want the how many molecules, the exact number of stuff here. So I got to convert my moles of H2. Remember, all the units left standing is moles of H2, and I got to get rid of moles to get the actual number. Well, what's the converting factor between a mole and the actual number? And that's 6.02 times 10 to the 23 molecules. All right, moles cancel. Let's go find that number. All right, so I'm going to take 100, times it by 1, divide by 94. That part is moles. Times 1, divide by 1. It's a 1-to-1 ratio. Okay, but we're not lazy. We write it anyway. Then I times it by 6.02. If I'm using a TI 80 something, I do second function EE to the 23. Enter that. And I get the actual number. It's going to be a huge number because they're asking for how many molecules. So these things are small. So it's going to be a huge number. Let's do 6.4 times 10 to the 23. And of course that's what? Molecules of what? Of hydrogen. And that's your answer. Everything cancels except for what? 2 things, hydrogen and molecules. All right, but what did we do here, guys? What did we do? Right here we did what? We converted to moles. You've got to see what we're doing. We had to go to moles because we were in a how many number? We're in a how heavy number, so we had to get into moles. Second step, this is the stoichiometry. All right? And this is what? Converting to the number of stuff I like to call. Okay, so 3 steps in this problem. All right, let's go on to the next couple of problems. Okay, we have to balance a reaction, and it looks like it already is. There's a 1 here, there's a 3 here, and there's a 2. So this was already balanced. Okay, so here's the first question. How many moles of H2 need to produce 4 moles of ammonia? Notice this is a mole to mole problem. This is 1 step. I write down the number given to me, 4 moles of ammonia. Now if you didn't know ammonia, it's NH3. This is hydrogen, this is nitrogen, so you only had 1 choice anyway, so NH3. And guess what? I'm already in a how many number, so I'm going to get rid of NH3. That's the stoich part of the problem. And they want H2. And there's 3 of these, I'm getting that from the periodic table, to 2 ammonias. And I'm going to cancel. It's a 1-step problem because I already have a number that's a how many. I can times it by this mole ratio, which makes it stoichiometry. So 4 times 3 is 12. Divide by 2 is 6 moles of H2. Write down the number, the unit, and what compound you're talking about. Everything is left standing except the moles of H2. That's it, 1 step. Second one, how many grams of N2 are needed to produce 17 grams? This is a mass-to-mass problem. So I've got 17 grams. Write down what's given to you first of NH3. That's my ammonia. I cannot times it by this ratio directly because it's how heavy. This is not a ratio of how heavy, it's a how many. So I have to convert to moles first. When in doubt, convert to moles. 1 mole is equal to how many grams? Well, we're going to have to do a formula mass. In 1 mole of NH3, there's 1 N. 1 times 14 is 14. I know my 1 times tables really well. 3 H's, when 1 mole ammonia is 3 moles of H's, 3 times the atomic mass of hydrogen is 1, and you get 17 grams per mole. All right, that's what goes here. Tired of red, let's go to the blue. So yeah, grams cancel, I'm left with moles of NH3. We just converted to moles. Now we're in a how many number, and now we can use the ratio. Okay, get rid of NH3. But the whole point of this stoichiometry problem is get rid of the compound given to get the one you're after. In this case, we're after N2. Now N2, there's 1 of them per 2 ammonias. I'm using the balanced coefficients. Cancel off my what? Ammonias. Now I have mole of N2. But they asked for grams of N2. So my last step, I convert to grams. Get rid of the mole. 1 mole equals how many grams of N2? Well, a mole of N2 is 1 N. Now 1 N is 14. 2 N's is 28 grams per mole. Okay, grab our handy dandy calculator. And here we go. 17 divide by 17 times 1 divide by 2 times 28. And you get 14 grams. Of what? How do I know I have grams? Because it's the unit left standing. Grams of what? N2. All right, N2 is left standing. That's my other answer. Okay, very simple. You just got to follow your units. Letter C, how many moles of hydrogen gas do you need to produce 51 grams of ammonia? Always start with the number given to us, so 51 grams of ammonia. And that grams is no good to me because it's not a how many number, so I get rid of it to get to moles. When in doubt, convert to moles. 1 mole of ammonia, what we just did, it is 17 grams. We get rid of it. And what are we after in this problem? We're after how many moles of hydrogen. So we get rid of ammonia. We put hydrogen here. What's the ratio? Go to the balanced formula. There's 3 H's to 2 ammonias. Changing my ink because I can. The ammonia cancels, and I'm left with moles of H2. Then whoa, they just asked for moles, right? That's nice. It's a 2-step problem. They gave you grams of one compound, and they wanted moles of the other. So this is just a 2-step. I have moles of H2 done. So 51 divided by 17. All right, times 3. Divide by 2, and that gives me 4.5. 4.5 what? 4.5, what's left standing? Moles of H2. And that's my other answer. Straightforward. Letter D, how many grams of H2 are required to react with 0.5 moles of N2? Put down the information given to you, 0.5 moles of N2. Now they want grams of H2. Grams of H2. But you gave me moles of N2. So I can take this moles of N2 and times it directly by the mole ratio. I'm going to get rid of N2 to get my H2. What are my ratios? Okay, ratios are there's 1 N2 to 3 H2. Okay. Get rid of that, get rid of that. So now I have what? Moles of H2, but they wanted what? Grams of H2. So my next step is to convert to grams. Get rid of my mole. I put that on the bottom, and some people don't see that. It's moles over 1, okay? And 1 mole is how many grams? We'll do a formula mass. The mass of 1 mole of hydrogen is 1, so 2 moles of hydrogen atoms would be 2 grams. Look what cancels, mole goes bye-bye, and we're left with grams of H2. Using our handy dandy calculator, 0.5 times 3 times 2, and that gives me 3 grams of hydrogen. Okay, last one, and that of course is our other answer. How about that? How many molecules? Wait a minute, that's a huge number. When you ask for the exact number of stuff, whoa, it's going to be Avogadro's number will be produced if 2 moles of N2 were used. Okay, how many steps? Well, if you have 2 moles of something, I mean, I want to go to something else, I'm already in a unit needed to get into what? The mole ratio part, right? Where's the mole ratio part? In every problem, we've got the what? Some problem, every single Stoich problem is using the balanced chemical reactions. Some are just 1 step, some are 3 steps, some are 2 steps. In this case, you gave me moles of N2. So I have 2 moles of N2. And I want to go from N2 to ammonia gas. So I'm already in moles. So get rid of N2. Ammonia's NH3. And let's go to the balance reaction because my short-term memory is gone at this height. There's 2 NH3s for every 1 N2. This cancels N2, and this gives me moles of NH3, and that would be great if it was a 1-step problem, but it's a 2-step problem because you gave me the moles and you want the actual number. Last step, convert to that number. Get rid of moles. Moles on top on this side, 1 mole on the bottom is equal to 6.02 times 10 to the 23, and that's molecules. Mole goes bye-bye. It's a 2-step problem. 2 times 2, my gosh, 4, divide by 1, times 6.02. If you got a TI 80-something, it's second function e to the 23. It's Avogadro's number, and I get 2.4, we'll stay there, times 10 to the 24. What? Huge number. That's molecules of, who's left standing? NH3. And there's your answer. 2-step problem. You start with moles. You went through the ratio. The ratio that makes the stoichiometry is right here. Every single Stoich problem is using that. But we needed to convert to moles. Oh, sorry, we needed to use the moles given right through this. And then once we go in, we convert the moles into the unit we want. So I hope you can see, party people, that somehow we're using the balanced chemical equations to convert from one chemical to the other. And then sometimes we have to convert. In the case of B, we had to convert to moles from the grams. In the case of C, we had to do that. Okay? All right. And in the case of D and E, we didn't have to because we were already in moles. But in D, you had to convert back out to grams, so that's an extra conversion. And in E, we converted to that number of stuff that we talked about. Okay? Hope you got something out of that.